kind of where I'm not complete with it yet. It's not completely done, but here's some of the things that I've done and lessons learned along the way in using Azure Machine Learning to try to perform lie detection. So let me start by kind of showing you, for those of you in the room, you can see I'm wearing this crazy thing on my head. And so this is a headset made by a company called Emotive. It's not made by Microsoft. It's actually a female-founded company. Woohoo! A woman by the name of Tan Lee created it, so it's Emotive. And it reads your EEG, or your brain waves. And so I saw Tan Lee do a TED Talk about this device and some of the things that I could do, like way back in 2010. And I have just been lusting for it in my heart, like ever since then. I really wanted this device. It was just, looked so cool. Like there were so many neat applications I could do with it. And so I finally managed to get Microsoft to buy it for me by doing some cool stuff with it using machine learning. So really, really cool stuff. So I had a whole bunch of ideas of, okay, there's so many neat things I could do using EEG and then machine learning in conjunction with it. So I thought about ideas like doing something like all baby whisperer. So I had a baby at the time, and when babies are really, really young, they really only have like 4 needs or whatever. It's like they're either hungry, or they're tired, or they're overstimulated, or uncomfortable, or like it's a small amount, but it is a limited amount. So I was wondering, if I put this on my child, could I learn to like predict and differentiate between all those different cries, the hungry cry versus the sleepy cry versus whatever. So I kind of had that idea first, and a couple, I actually have a million other ideas as well. The first one, that one didn't work out, the baby whisperer, because Microsoft's procurement process actually takes a while. So I ordered the device, and like 5 months later I got it, and by that time the child was like talking, so it was like, okay, that's not going to work anymore. So the next kind of fun idea I had was thinking about lie detection. And so I took the headset and I put it on my husband and asked him a bunch of questions. And first I asked him to tell me the truth, and then I had him lie to me. And what that gave me is a labeled data set of here's what your EEG looks like when you're telling the truth, and here's what it looks like when you're lying. And so from there, you can take that labeled data set and feed it into Azure Machine Learning to build a classifier to do lie detection. So that's what we're going to talk about today. Just for context for me, how many of you guys were in my earlier session on the Titanic and using Azure Machine Learning? Okay, a lot of overlap. Okay, so there may be some redundant slides, but maybe I'll go a little faster through those then, because I explained some of the same basic principles, but that was already done earlier. Okay, all my contact information is up there. If you have questions afterwards, I know I've been running in and out because there's been some press interviews as well, but if there's anything that does not get answered, please feel free to reach out to me on Twitter. I have a blog. I'm pretty easy to find online, so just let me know. Okay. All right, so let's start by taking a step back and what is EEG? Like, what is this actually doing? And so for a definition, we of course turn to the source of all knowledge, which is Wikipedia, right? So you can see the official definitions there about the billion neurons in the brain and kind of the electrochemical signal, but essentially what this is just a non-invasive way of being able to monitor those electrochemical signals that are happening in your brain in a way that doesn't harm you or anything. You're just kind of passively reading that information along the scalp. And so that's what I'm doing. And I do want to call out, I think everyone in this room is probably intelligent enough to know this, but just in case, I used to call this talk Fun with Mind Reading, just because that was a catchy title. But I remember I submitted it to a conference once, and it was one of the conferences where they actually give you feedback on why they do or don't accept you. And they wrote back this review of, that is not mind reading what you are doing. And it's like, yeah, I mean, obviously, this isn't mind reading. But just to be really clear, I am not doing mind reading here. If you have this headset on your head, I cannot tell what you are thinking. Okay? But what I can do is I can create mappings between patterns of EEG and actions, either actions in the real world or actions in the digital world. And I'm going to show you an example of that in just a second, and some examples of what other people have done, like make a drone rise like with the power of their mind. And then the other thing I can do is I can collect data and then find patterns in that data using machine learning techniques to be able to make then predictions in future data that I've gotten, okay? So those are some of the things that are possible today. Now, just taking a step back, I want to show you kind of the power of this headset and what got me excited about it. So we'll kind of start with a little bit on the headset, then move on to kind of the problem that I was trying to solve, and then the Azure Machine Learning component, and then kind of tying it all together at the end. So there's a couple of different sections here. So let me start with just like this headset and kind of what got me excited in the first place, and that idea of mapping your brain activity to actions in the real or physical world, or virtual world. So what I'm going to do is I'm going to use a tool. So this is something that was not written by me. This is something that was created by the folks in the people in the Emotive, people at Emotive. So this is a piece of software that comes with the headset. And so it shows you some of the things that are possible. So I'm going to start by just jumping over to this expressive suite. So first of all, you can see there's a whole bunch of green little dots right there. So those green dots on the head, so that's actually a diagram of the head. That thing at the top that sticks up is the nose. So you're basically seeing my head like this, all right, the top-down version of it with the nose sticking out and the two ears on the back. And right now, they're all reading with full signal strength. So that's why all of them are green. So everything is good right now. For those of you who come here early, you may have seen me like frantically shifting chunks of hair around and putting more saline solution on to make it read well. The way this particular headset works, I'm using what's called the Epoch Plus by Emotive. And it has a little felt tips, I guess, or little felt pads that have to screw into the headset. And you need a wet connection to actually pick up that electrical activity. And so before, when I got here way early to get set up, and I just used regular saline solution, the same thing I use for my contact lenses, actually, makes traveling easy. And then I just put a little bit on each one of the sensors before I screwed it in. And then I kind of have to usually mess with my hair a lot to make it pick it up well. It's so funny because every time I've ever seen like the Emotive team do a public demo, they always do it on a bald guy. Like always, like no questions asked. It's like bald guy, oh, let me choose a random person from the audience. Bald guy, come here. And then, because you just like put it on a bald guy and it just works. Like it's amazing. For me, it's like a 20-minute long process where like I'm putting it on, I'm shifting chunks of hair around, and so, all that stuff to get a good signal. But that's kind of how it works. And I'm going to talk a little bit more about the levels. They actually have an enumeration of different levels of signal degradation that are possible. So we'll talk a little bit more about that in a second. Then let's kind of see some of the stuff that they give. So first is the expressive suite. So I have not trained this one for myself, but let's see if we can get this. So I'm obviously, I'm going to blink my right eye. I'm not looking up there. Is it working? And then blink my left. Yes, yes. Okay, I'm going to look to the right, then look to the left. Is it doing it? No? Yes? I'm seeing some yeses and some nos. Yeah. What's that? Oh, okay, there's a delay. Yeah, there will be a little delay. Smiling, raising your eyebrows. And I haven't actually tuned this one to me, so it's not always, space. So you can see some of those things. And so the point I want you to take away from this is the fact that it's actually recognizing, like they have some algorithms that they wrote to try to recognize facial expressions. So what that means is that facial movement is actually picked up in EEG data. So that's the takeaway I want you to get here, all right? So what that means is that EEG data is actually really, really messy. It's noisy, noisy data. So if I can go like, as I make facial movements and that's reflected in there, if I'm taking data then to try to determine whether someone's lying or not lying, I don't want kind of this, these things picked up in my data. Or maybe I do if they have facial twitches. So just something to keep thinking about, all right? So keep that in mind. That's kind of the early thing, and we'll come back to that. There's some other things too. So this kind of, this one is, I'm going to skip over this one. It's, but this kind of gives you your emotional level, like how kind of your excitement level and what those kind of look like versus meditation and such. And then what I want to show you is this. So this is something, this was one of the things that got me super excited about this device. But this is the idea of, again, mapping patterns of EEG to either real things in the physical world or the virtual world. In this case, the virtual world. So what I'm going to attempt to do right now is move a cube with the power of my mind. So the first thing I'm going to do is just, you see there's kind of two things here. There's first a neutral state. So what we're doing by training at a neutral state is I'm going to just take, it takes 8 seconds to train, so I'm just going to take 8 seconds, go to my happy place, and just think about nothing in particular and just try to relax for 8 seconds with a room full of people staring at me. And there's going to be an awkward silence, and we're all going to be okay with that. And then I'm going to have my eyes closed, so will someone just scream when just yell something, like open your eyes when the 8 seconds are up? So we're going to start with that. And what that does is give kind of a baseline, right, for my mental activity, right? Because when you think about everyone's brain has a unique signature, and so things like this allow you to normalize the data across all these different brains. So for example, my husband's brain might, my brain might peak at like 24, and my husband's brain might peak at like 3. And so you want to normalize that across all people. So here's what we're going to do. We're going to start with just getting a neutral state. So again, I'm going to go all zen, and then we're going to 8 seconds, yell when the 8 seconds are up, and I'm just going to try to completely relax so it can get a baseline of my mental activity. All right, and here we go. Thank you. Okay, so it said neutral is completed. I'm going to say yes, that's fine. So it updates with that. So now we have this neutral state. And now there's actually a number of things you can have the cube do. You can make it drop and lift or rotate it, those kind of things. I'm actually going to select pull because that's a really fun visual of the cube coming towards you. So what I'm going to do now for 8 seconds is actually go all Jean Grey and think pull, like with my mind, for 8 seconds straight, okay? And so I don't actually have to be thinking the word pull or whatever, right? You could be thinking hamster dance, and that would be fine. It just, as long as you consistently think whatever that thing is when you want the cube to pull, because we're just mapping, again, EEG data to a specific action, right? All right, so this is we're mapping to the pull action, so I'm actually going to think pull in my mind for all this time, okay? So here we go. Ready, set, 8 seconds. I'm going to think pull. Okay, so here we go. I'm going to hit yes, and now the cube is live. So I'm going to repeat that and try to think pull again and make the cube move towards me. All right, let me give it one more training because I was kind of distracted there. Okay, so we got that. Now, here we go again. Pull. Wasn't that awesome? Okay, let's do it again. Let's do it again. Pull. Cool, right? Isn't that amazing? Let's just do that for the rest of the talk, okay? All right, so you saw that you could do some pretty cool things. So we had this ability to take some of the things in your mind and be able to map that to real kind of real activity. So mapping a mental action to real things. So let me go ahead and just show you some of the other things. So this is just a short snippet of part of that TED Talk that shows what some other people are doing in the industry right now with this kind of technology.
Your facial expressions can naturally and intuitively be used to control an avatar or a virtual character. Obviously, you can experience the fantasy of magic and control the world in your mind.
That is actually really cool. Think about that, like able to have something respond to your emotional state. Like imagine gaming and being able to, here, let me pause it where I started there. But imagine having something be able to respond to your emotional state. So a game where there's like real-time feedback where if I'm starting to get like bored or tune out, have another zombie jump out, right? Like that's kind of a neat feedback loop, being able to make, really use the person's emotion in the context of a game.
And also, colours, lighting, sound, and effects can dynamically respond to your emotional state to heighten the experience that you're having in real time. Moving on to some applications developed by developers and researchers around the world, with robots and simple machines, for example, in this case, flying a toy helicopter simply by thinking lift with your mind. The technology can also be applied to real-world applications, in this example, a smart home. From the user interface of the control system to opening curtains or closing curtains.
I like curious to do, this is not the droid you're looking for. Like with that, did you notice that? You had the hand movement.
Turning them on.
This one is my favorite.
And finally, to real life-changing applications, such as being able to control an electric wheelchair. In this example, facial expressions are matched to the movement command.
Now blink right to go right. Now blink left, turn back left. Now smile to go straight.
We are really
Okay, so you guys saw some really kind of compelling things there. There's obviously some really cool application in gaming and other industries, but I love the idea of my favorite one is the one at the end, like the smart home, that's kind of cool too. But the idea of a paraplegic or someone paralyzed from the neck down, being able to use either facial expressions or mental commands to be able to make their life easier is like a really, really amazing thing. And like those are the scenarios, like the machine learning scenarios that really get me most excited. Okay, so with all of these wonderful things we can do to help humanity, what does Jennifer choose to do with the device? Lie detection on my husband. Yes. Way to help humanity, Jennifer. So what I started thinking about when I was first thinking about this scenario is I was thinking about some of the issues that people have with typical polygraphs, right? You guys have probably read the same articles online that I have. And seen the same crime drama, CSI whatevers, that show kind of people beating polygraphs. But there's a lot of critics of polygraphs who complain that it's not as effective, it's not really that effective, because it really measures kind of your emotional state, like how emotional you are, rather than guilt. So if you're really, really nervous and things like that, sometimes those things can make a difference. So it measures things like your heart rate, galvanic skin response, like the sweatiness, rate of breathing, like all of these types of things. And so I started thinking, like, and I'm sure you've seen like that people, these people in these spy shows and stuff all beat the polygraphs by either really controlling your mind or doing things to simulate distress. So usually truth you're pretty relaxed, but then when you lie you're kind of more antsy or anxious about it, and that's how they figure it out. But there are scenarios where people have like a tack in their shoe or something like that, and then when you're telling the truth you step on the tack, so that simulates like a stress thing, and then you lie, and you're still at a high stress level, and when you're telling the truth, step on the tack again, so that way you kind of are keeping a consistent level of anxiousness, and then they can't differentiate between truth and lies. So there's kind of little things like that people have talked about, and I don't really know how accurate they are since I've never taken a polygraph. But things like that's like, okay, could there be a better way? And I started thinking about this EEG. And I am not a neuroscientist. I do not claim to be. That's not my field. But I did take like one brain science class back in college, and one of the things that I remember is that when you tell the truth, you're typically activating the recall centers in your brain. And when you lie, that typically activates the creative centers in your brain. And so I started thinking, if I have this headset that reads 14 different places on my scalp, could I be able to differentiate between those? Is that possible? And so it was something that's like, I don't really know, but let me just try this and see what happens. And so that was kind of the goal, and in good little former graduate student fashion, I listed out here's my goal, can I use EEG data to predict if someone's lying, and kind of wrote out all the tools as well. So let me get down to the procedure. So I started this, my very first experiments were all on my husband, Eric, the sainted person that you have seen in the keynote. And the procedure that I used is I had him sit down in a chair, and I had him kind of relax his face and such and close his eyes. And I had him close his eyes for actually 2 reasons. Number one, I wanted his face relaxed because you guys saw with that there was all kinds of, remember how with the facial movement that actually is affected in EEG, and I can actually prove it to you too if I bring up this. So this is Test Bench, which is the thing that I was using. So this is reading my brain activity right now. Ooh, I was doing something interesting there. But if I move my face, you can see that affects the data right there. And then I kind of go back to just normal. And then if I do a bunch of stuff on my face, if I'm scratching my face, there are so many bad pictures of me on the internet because of all these crazy faces. You can see that data all gets picked up too. And so one of the goals was I wanted my data set to be as clean as possible when I was training this. So I had my husband sit with his eyes closed, face relaxed, so that he wouldn't, bring unnecessary facial movement data into my data, because I wanted it to be as clean as possible so I could focus on the kind of lie part of it. So that's one part of it. Then I also, the second reason I had him close his eyes was because I was reading these questions to him, and I was kind of sitting right next to him, and I didn't want him to be reading the questions over my shoulder, because I was trying to actually put markers in the data to be like, here's where I started asking the question, so that way I could, with all of this brain data, I could parse out just the part where he was thinking about his response and replying to kind of zero in on, where that lying might be happening. And so because of that, I didn't want him reading over my shoulder, because then he would start thinking about the answer earlier, and then I couldn't pinpoint and get that data as narrow as I wanted. So he had to close his eyes, and those were the reasons. And then I ran that tool, Emotive Test Bench. I can run it, jump back over there and show it to you. But I asked these questions, and these were the initial questions that I asked. They were all very clear-cut, like yes or no questions that have an easy answer. None of them are really ambiguous, like the does this dress make me look fat type question, where it's like, there may be kind of something in between yes or no that is the right answer. So these should all be very clear-cut. And then, and I did also make sure to ask some where the correct answer was yes, and some where the true answer was no. And that was because I wanted a nice confusion matrix of, yes, no, true, false, where there was something in each of those quadrants, if that makes sense, okay? So, like, for example, does he have a PhD? Yes, he does actually have a PhD. Does he have red hair? No, he does not, that kind of thing. Do we have 5 kids? No. Well, actually, I don't have 5 kids with him. If he has 5 kids, then we have another problem. But as far as I know, we only have the 3 that we have together. So there's a whole bunch of questions that I asked. And then I asked them out loud, and then I annotate the data with these markers. So let me show you the markers real quick, just in here. So again, I was running this test bench thing. And so I could see all of his brain activity as it was going by. And this is kind of a cool tool. So it has all 14 of them activated right now, but you can actually turn some off if you want to see less channels, if you want to focus on certain channels. I can turn those back on. But those correspond to those 14 different nodes on my head. And then it is taking, it's sampling at a rate of 128 readings per second. So if you do the math on that, that actually works out to approximately every 8 milliseconds. It's taking a reading, all right? So you're getting a lot of data here. And then what I was doing to get the markers is I went here, and there's this marker thing where you can send markers manually. And where would I have put this if I was Jennifer? Under emotive work, and here's some. These are some early ones. I think Data 2 probably has a better one. Yeah, let me grab those. So these are some later ones. But like, so at the beginning I asked, okay, when was the question asked, and then sent to marker. And if I hit send, you see there's this little 1 that shows up in the data, and so that will appear in the data exactly in that millisecond reading or the next millisecond reading where I said that. So I can then ask the question and send a 1 like before I ask it, and then say a 2 after he finishes answering if I want to just parse out that whole thought process right there. So that's the way this data works. And then you can hit save data and load data to actually then start recording all this data, so it's all being buffered and recorded. So I did that, and I can show you what the data actually looks like. We can close that. Oh, I should have had one of these open and ready, but I did not, sorry. So if I go here to, let's do data 2, and hopefully we can get a good one. Let's try this one. And I'll close all that. I'll look at them later. Okay, so is this one good? Let me make sure it's all processed. Yeah, this one's good. Okay, so here's kind of an example, and let me zoom in a little so you guys can see it a little better. But here's all of the data that's generated, and then I actually added some additional columns of data on the end. So the first thing is this counter. So the counter actually, just since it's taking 128 readings a second, it actually counts up to 128 and then resets itself. So it's just a counter that just keeps going over and over again. I'm throwing that out. I'm not using that data point at all. This I'm also throwing out. So these are the actual 14 interesting data points. And you can look at them right now and see that they have names like AF3 and F7 and F3. And I will show you in just a second when we jump back to the slide deck where those correlate to the different positions on the head. So we'll come back to this in just one second. So those are all of the data points. So those all 14 columns. And then I have this, there's actually a little gyroscope in there. So you kind of get the XY acceleration movement. And I'm not using that in my data either. But there might actually be something to that. Like, have any of you guys, is the World Series of Poker, like on TV, is that popular here? Yeah, okay. So you can see that sometimes people have tells where they may tilt their head, or they might do some interesting things. So there might actually be some signal in there, but so far I haven't used the gyroscope stuff. Here's the marker column. So this comes through as all zeros, and then I was putting them as ones, like when we started the conversation, and then I was doing like a 1 and 2, so then I could parse out everything between 1 and 2. For example. So the markers allow me to do that. And then the timestamp, so the way they do timestamp is they actually have the timestamp in seconds and in milliseconds in 2 separate columns. So I actually threw an additional column on the end where I do seconds times 1,000 plus milliseconds to get it all in one value to make math easier. So that's how they do it right there, but I'm overwriting that later. And then all of these CQ values, so you'll see there's actually CQ values for each of these 14 nodes as well. And that stands for contact quality. And that actually represents an enumeration of how well these signals are reading. So if any of you guys, I don't think the screen was being displayed earlier when I was getting set up, but like right now everything is green, and green is actually a 4. The value is 4. So you can see that right here, once this stuff gets up and running, these values are all turning green, so it's good signal. And when you first put it on, it takes a second. So you can see these all turned green, and then these will all turn green over time. And so then once they're all green, that means it's okay to start working with it. So that's really good for data cleaning, is I can see when my signal strength is less than optimal. So if some of them are like black, for example, or which is 0 in the data, I don't want to use that data because I'm not actually receiving any data from that, and I can't trust those results. So that's a nice thing to think about when you're doing data cleaning and trying to figure out how to utilize the data best. Okay, so that's the next thing that you get from there. All right, then everything after this, I added myself. So these last 3 columns, the is truth, time, and user ID, these I added myself. So is truth is my label column, where I took, am I asking them to tell the truth, or am I asking them to lie in this particular experiment? And so I put that label in there so that way I could, use that in the machine learning algorithm for here's the EEG that's lie and here's the EEG that's truth. So this was a truth run, and so that column is 1. And then the time, again, this was me just doing milliseconds plus seconds times 1,000 to get the time in one value right here. And then finally, after doing some of this initial work with my husband and my manager and all of that stuff, I've actually been trying to see if, can I build a general purpose lie detector that would work on anyone? And so that involves normalizing data across a lot of different people and collecting data from a lot of different people. So I've been asking people if they want to give me data, and here's what I would take, and here's how I would use the data, and all those kinds of things, and being very open and transparent, because that's really important in data. How are we using these things? So I kind of listed out on a piece of paper, here's all the stuff here's how I'm going to use it, here's what I'm collecting, all of that stuff. And so people made sure that they were completely bought in before doing it. And I also, just for privacy's sake, gave everybody an ID, so you can't go back and figure out, okay, whose brain data is this, in case somebody wanted to do that. All right, so this is user 20, whoever that is. All right, so, and that was good just in terms of building it and trying to expand the work, which I'll talk about in a little bit later. All right, so that's kind of what the data looks like. And I'm storing this all in CSV format. So TestBench, what they actually do, this data is stored in a proprietary format that's proprietary to Emotive, but then they have a converter right here in the tools, which is to convert their own format to CSV. So then I just store it in their thing, convert it to CSV, and then Azure Machine Learning accepts CSV as one of the formats. So then I would upload it into Azure Machine Learning in the CSV format. Okay, so that's that. And that was the experiment procedure. And the subject replied to everything with a yes or a no, so I made them all very yes, no. Eyes closed, minimal facial movement, because I didn't want messy stuff in my data. And then I did this for truth and lies, just to make sure that I had a training set where I had both true data and lie data. I needed both sides, so I did it multiple times together, both of those things. Okay. Again, here's the testing process, and my poor sainted husband, who is participating in this, and oh, the jokes just write themselves. There is my poor husband. And so what we're going to do next is I wanted to talk briefly about the signal quality. Again, the display shows various colors for that enumeration. And so we have green is the maximum signal quality. When I was doing my work, I wanted to use only green data, the highest quality data, to make sure that all of the sensors were reading properly. So I did some data cleaning to make sure that was the case. Then we also have, it'll change to yellow, which is a value of 3, and then orange, and then red, and then black, which are all progressive levels of signal degradation. All right, and then it's just an enumeration, so very easy to do. But I grabbed a couple of screenshots of when it was not quite perfect, just so you could see what that looks like. All right, and then here is where those numbers that you saw in the Excel spreadsheet mapped the various positions in the brain. So AF3 and AF4 are these ones right here in front. O1 and O2 are these ones here in the back of my skull. T7 and T8 are over the ears. So you can see kind of where the various things map to different places on the brain. All right, so then the next thing I kind of did was look and see, has anyone else thought about this? Because oftentimes when you have a great idea, you're like, oh, somebody has already got to have thought of this. This has got to be some cool research on there somewhere. So I went out and kind of looked to see, hey, has anybody thought about using EEG with lie detection yet? Just to see what was out there. And in fact, some government agencies have been looking into this already. And one of the things that I found was something called, some work around something called the P300 ERP. Now, ERP stands for Event-Related Potential, and that is a way of processing EEG where you're not working with just that raw data because it's so messy. ERP kind of helps normalize out some of that data. And so what the ERP actually measures, or what it actually is that that blast of recognition. So imagine that you're here at Microsoft Ignite New Zealand, and you're walking through the crowd, and you see a face, and you know you've seen that person before, and you get that flash of, oh, I know that, and it's your brain pattern recognizing, right? That you know that pattern, you know that facial structure, you've seen it before, and you get that flash, all right? And so that's essentially what the P300 ERP is. what it looks like on a waveform is this little dip that you see right here, this little P3 dip. And the reason they call it the P300 is because it occurs roughly 300 milliseconds after the stimuli appears. And so you can see kind of what that looks like. And so how the government agencies are actually using this is, instead of asking yes or no questions like you'd see on a typical polygraph, they're actually doing things, image-based recognition, right? Where you'd sit someone down with an EEG reader and then show them a series of images. And maybe you show them something like, a couple just neutral images of whatever, cats, whatever you want to do. And then show, a picture of the crime scene or the murder weapon or whatever, something that only someone who had intimate knowledge of the crime would recognize. And so then at least that gives you the data that, oh, this person has seen this before, or this person may know more than we think they do, or more than they're telling us maybe. And so these charts are a pretty simple way of saying if it correlates with stuff they should know, then they're good. But if it correlates with stuff that only someone who participated in the crime would know, then they might be guilty. So that's another thing that they're doing. And so it's different than what I'm doing because it's measuring something different. It's not using yes or no questions. But what was actually really useful about this research is one of the things I was worried about was essentially the sampling rate. I didn't know if that was enough, right? Because it's sampling, as I said, every 8 milliseconds. And when I was thinking about it, I didn't know, I couldn't remember, okay, how fast do these brain responses actually happen? Like the decision to lie and not lie, and like what's the time frame there? So this at least gave me some sense of, okay, that flash of recognition is happening in hundreds of milliseconds, so I'm probably okay with my sampling rate. So that was some neat knowledge I got out of this as well. So kind of cool stuff. All right, so now let's jump into Azure Machine Learning, and my apologies, this is going to be slightly repetitive for those of you who saw my talk yesterday, but just wanted to kind of give you some of the basics of Azure Machine Learning and what you can accomplish with this. So Azure Machine Learning does have 25 different machine learning algorithms. It's a browser-based system where you can drag and drop different modules, wire them up together, and be able to do things like predictive analytics or clustering or things like that. And so there's a lot of modules in there to do common tasks that a data scientist would want to do. So things like, changing the metadata or making things categorical or not categorical, or filling in default values or throwing out data where there's missing values or things like that. So there's modules for a lot of these things, and then you can basically train and test a model all within Azure Machine Learning. And then it's literally a button click to deploy that model out. It gives you kind of that security, that API key to call the model and be able to get some really good results back in 2 modes. You can do a batch execution mode where you send up a bunch of data and have it process all of it at once, or request response where you send up kind of a single set of data and get one response back. So we have all of those things possible with Azure Machine Learning. Here's a template for what supervised machine learning might look like. So you start with some kind of data set, and then you'd apply various data cleaning things to it to get the data in a shape where it can be easily consumed by a machine learning algorithm. And if you're curious about some of the things that you might do in data cleaning, please go back and watch the recording of my other talk of the Azure Machine Learning to predict who would survive the Titanic. I go through a little bit of like the thought process behind data cleaning and how we might modify data in that talk. So we do some kind of data cleaning stuff, and then we split our data. And the reason we split our data is because we don't, if you give it 100% of your labeled data set of here's all of these features that all affect this label, so all of these things are influencing factors that affect this thing that I'm trying to predict. If you give it all of that data, and then you want to train it with that, and then you want to test it, it's going to perform really well if you just give it the same information that it's already been trained on. So you need new data, because really the test of how well it works is how well does it do on data it's never seen before. So for that reason, we typically take a subset of our data, which is the majority of the data, but still not all of it, and train just using that, and then take the remainder and use that to test the model and see how well it performs. And so in this case, there is a split module within Azure Machine Learning to allow you to split your data. And the industry standard could be 70-30 to train with 70% of the data and test with the remaining 30. You can also do 75-25, 80-20, lots of options. but usually the majority is your training data. And then I would take this training data that I took and use that to train a model, and then I would use some algorithm, which we'll talk about in a second, to train the model. And then I take that trained model that it produces based on here's the data, and then the algorithm gives you the kind of math you want to do to draw correlations between those influencing factors and the thing you want to predict. And then what you can do is it spits out that model that can generate stuff, and then you apply that test data to the model here in the scoring option. So I send in, for this EEG data, is it a truth or a lie? And then I can compare it against that 30% of data where I held back, where I know the answer of whether it's a truth or a lie, and see how well it performs. All right, so that's what that score module or model does. And then finally, you can do the exact same thing, like repeat this process over here, and then be able to then say, all right, let me try this, but let me try it with a different algorithm and compare two algorithms against each other and see how well they do. And then once you land on an algorithm and you're happy with one particular algorithm, you can tweak the initial parameters in that algorithm and then compare those against each other to see how well they do, and kind of be able to continuously iterate and develop the best model for your problem. All right. So then I can compare those two things next to each other in this evaluate model, which will show you side by side kind of how they're performing, what their accuracy numbers are, that sort of thing. Okay. And so the next question you might have is, okay, maybe that all makes sense, but how do I choose which algorithm? If I don't have a data science or a machine learning background and there's 25 different algorithms in Azure ML, how do I know? Like, what's the way to figure it out? And the answer to that is the Azure Machine Learning Cheat Sheet. And so what that actually gives you is a whole lot of information on how to, where do I start and where do I go with this. So you start in the middle and then make a decision based on if you're trying to find unusual data points, you could use one of the anomaly detection algorithms. If you want to find kind of groups of like things and discover structure in your data, you can use a clustering algorithm. And then if you want to be able to predict like a number or a value on a continuum, you can use a regression algorithm. Or if you want to predict kind of discrete buckets, one of several options, what you might think of as an enumeration if you're a developer, like those kind of things is a classification problem. And so in this case right now, trying to predict, if I'm trying to predict whether my husband is telling a truth or lie, what is that? What kind of algorithm would I use to solve that? Classification, right, it's classification. Is it two-class classification or multi-class classification? Yeah, two-class. I was trying to make it very clear-cut, truth or lie, not the does this just make me look fat thing. So yes, we were doing truth or lie. So yes, that is right. I was using two-class classification right here to determine truth or lie. So, and you can kind of dive into those, and then it tells you in a declarative fashion kind of here's what each algorithm is really good at. SVMs or support vector machines, those are really good if you have lots of features. The boosted decision trees are really, really accurate, but they take up a lot of memory. So that's something to keep in mind. So there's kind of what each of them is good at is kind of listed out there. So you can kind of take that information and give a sense for what to try first. And what I usually do if I don't know anything about the data set is I will try both a linear and a nonlinear algorithm first and see which one kind of performs better, and then iterate from there. All right, so if you would like to download the Azure Machine Learning Cheat Sheet and check it out for yourself, it's available at aka.ms, Azure Machine Learning Cheat Sheet. And then to get started with Azure Machine Learning, I have a blog post out there as well that gives you a lot of information on where you can find cool data sets, and then a walkthrough of kind of an end-to-end scenario using Azure Machine Learning, and a lot of other really great resources. So you can check that one out. That's aka.ms, hackml. And I wrote it for a student audience, so the title is How to Win a Hackathon with Azure Machine Learning. But you can just ignore like the first paragraph and read the rest of it. And the rest of it is just how to get started with Azure Machine Learning. And then finally, the last one is I have a video end-to-end walkthrough demo of the Titanic scenario. You can either watch it from the Ignite thing, or I put it on Channel 9 a while back as well. So you can check that out too. All right, so now let's take a look at the early prototype. So let me be really clear, this one is not doing lie detection per se, it's just seeing, can I even differentiate between the lie session and the truth session type data? So if I take a look at what I was doing here, I started with my truth data and my lie data. I was combining it together. I did some metadata changes to clean up the data a little bit. I threw out some stuff, split the data, and just tried a few other things. And then I'm doing like Python scripts and other things. But if you just kind of look at this early thing and visualize this data, and I was using here a logistic regression and a decision jungle to get started. Here's the ROC graph. So what this gives you is a true positive rate and a false positive rate. And so this diagonal gray line, which is usually very hard to see on projectors, across the middle is like 50-50 random chance, a monkey flipping a coin. So that scenario, you want to do better than that, and you can see both of them do. And then what perfection would be is false positives are bad. You don't want, that's when it thinks that something is true when it's not. And then true positives are good. That's when it thinks it's positive when in fact it is. And so in this scenario, like if you had 0 false positives, it would hug all the way across the top here. And then like 100% true positives, it would go all the way across here. So really you want something that will hug this curve as closely as possible. And you can see the red line actually does a decent job of doing that. So the blue line that we see here below, if we scroll down here, we can see it actually has an accuracy of about 71%. So that was using the logistic regression algorithm. And then this one right here, the burgundy line that you see there, that one was using the decision jungle. And you can see here all of the data that had an accuracy of around 93%. And so you see right here we have listed out the number of true positives and true negatives. You want those to be high. Those are good. And then the number of false negatives and false positives, those are low. You want those to be low. Those are bad. And then you have numbers for accuracy, recall, precision. And then accuracy is important, but precision and recall are also important too, because they kind of give you a sense for how well your data will expand to additional things, because sometimes people can like overfit and get higher accuracy, but you're basically finding signal in what is essentially noise in your training set, so you're overfitting it just to your training set, and then when you give it new data, it's less accurate. And so precision and recall can sometimes help with that. And then F1 score is a combination of precision and recall, and then this overall AUC, that stands for area under the curve, is about 98%, which is good. And then we get some bucketing here too, where it kind of breaks down all of these by bucket. So a lot of good data that you get here. So that was when I kind of saw, okay, initially this looks like this, there may be something to this. Let me, keep going, and I tried. I did some Python. I've done a bunch of different things, and I'll talk through them a little bit. But the next step is I kind of had some early results and was like, oh, this is really cool. And that was when my team had the offsite, right? So I work on a distributed team. So I live in Michigan. My manager lives in Minneapolis. Those are both very cold places in the United States, but they're actually kind of far apart. And what he did was, I literally, so this, everything you saw at the video that you saw, I did not tell him the questions I was going to ask. Like, that was all happening literally live. I'm like, I would love to be able to, get your brain data. Would you, are you willing to help contribute to this machine learning project that I'm working? He was like, yeah, sure, that sounds cool. And so then we happened to have this Channel 9 film team there, just because we were doing a lot of videos at the time. So I grabbed this cameraman. I'm like, can you just please record this? And honestly, like, that giggle could not have been better. I was like, oh my God, that was so awesome, so perfect. But this was all completely natural. So I did the same thing that I did with my husband. So I had to start by asking him to tell me the truth to a bunch of questions, right, to get a training set specific to my manager's brainwaves. So first I had him tell me the truth to a whole bunch of things.
Are you female? No. Are you a man?
Yes.
Have you ever worked for Microsoft?
Yes.
Are you age 40 or older?
No.
Et cetera, et cetera. You guys get it, right? Okay, so asked him a bunch of truth. He answered truthfully to the first thing. Then I asked him to lie to me. So we did the lie data. So I gathered the other half of my training set, which is what his EEG looks like when he's lying. Nope, that's not the right button. does not.
Yes.
Nope.
Do you have blue eyes?
Yes.
Is today Monday?
Yes.
Do you believe this is yes?
Okay, so a whole bunch of other questions where he was lying to all of them. All right, so now, what would you guys do if you had access to your manager's brainwaves? So I asked him actually a whole bunch of questions, but here are two of them.
Do you believe Microsoft is the best company in the world to work for?
Yes.
Am I going to get a promotion this year?
Okay, so you can see like how that wonderful awkward giggle that he gave, and of course, I what does that mean? I had to know what that meant right away, and so of course, I did what any girl would do, ran back to my hotel room and built a classifier with his brainwaves. So we did that. And here is, and then I'm sorry, you guys, I am not a UI person. But I wrote this very, very ugly Windows 10 application to actually call the publish web service. So to be really clear, I uploaded all the data. I built and trained a model that was specific to his brainwaves, right? Hit deploy on that so it's exposed via a REST endpoint. And then this Windows 10 application then can call the endpoint with new data to get information. So I trained it just on the truth and the lie data that we collected earlier. And then I called it with the 2 questions that I asked at the end, all right? And so now, here are the 2 questions, just to refresh you. Do you believe Microsoft is the best company in the world to work for? He said yes. My algorithm says, oh! He has an iPhone. And he's really into design. I'm just saying, we might have a closet Apple fanboy on our hands. And then the real good question that I really wanted to know the answer to, am I going to get a promotion this year? He said yes, and woohoo! Yes, I did in fact get the promotion. So we do have a review cycle, and I did actually get the promotion. So it said truth, and it was in fact true. And what's really funny about this is Mythbusters popular in New Zealand? Do you guys watch Mythbusters? Okay, so like when I had this, so again, this is not very good in terms of like here's my UI, what I was picturing in my head versus what I can actually do, because I'm not a UI person. I'm an algorithms girl all the way. But like, so what I was picturing is like, oh, it'd be so cool if I could have like the Mythbusters font, like, and have it say like confirmed or denied, just like that. And so I did actually like search the internet for like the Mythbusters font and found somebody did have a Mythbusters font out there. So that is the actual Mythbusters font for the truth and the lie right there. So, oh, I love the internet is the point of that story. Okay, so truth, all right. So very, very cool stuff. Super exciting. You can see super easy to call an Azure Machine Learning Web Service. It's literally like a REST call. Very, very easy. So what I've done since then is actually been trying to refine this process to make it work well across all users. And you guys can't read all that. So let me just call out some of the important points. I've taken additional data runs since my husband and my manager. And so some of the things that I've done differently are first multiple markers. So the first time I ran it on my husband when I had test bench up and it was doing those waves like you saw, I was just actually marking like right after I'd finished asking the question, and then I was kind of grabbing a set time around that. And so I revised that and started taking a marker before I started asking the question and right after they finished talking, so I captured the whole process. And it was a little bit more accuracy, so that's one change I made. And we've actually done a third data run and a couple data runs since here. But here's some of the things I've added. The multiple markers was one. The second was the neutral brain state recording. So that's another thing. Each brain really does have its own unique signature. And when you think about it, it's very similar to like voice recognition, right? We all can say the same words, but our voices sound a little bit different, right, when we say them. Different timbres and pitch and all that other stuff. I don't know music theory, but that sort of thing, right? So I started taking a neutral brain state recording. And you even saw, right, when we were doing the emotive, when I was moving the cube with my mind, that it was using that neutral brain state recording to kind of get that sense of here's what normal looks like for this person. So I started collecting that so that way I could utilize that data as well and then be able to use things like differentials and normalization and such to be able to do a better job of making something general purpose that would work on anyone. All right? The next thing is I asked more questions. So my initial questions to my husband only had like 8 questions that I asked. So I've made a slightly longer question list. This one's kind of interesting. So what I was doing too when I started collecting data is that, like with my husband and my manager on these first ones, I would always ask the true data first, or ask them to tell me the truth first and then have them lie to me. And it's actually kind of fun, like, oh, here's this crazy lady that's talking to me and having me answer questions, ha ha ha, and I have this thing on my head, and oh, this is kind of fun. But then it gets boring like really fast. All right, when there's someone asking you a bunch of questions, you're like, yes, no, right? And so there's this concept of fatigue effect, right, where at the beginning you're kind of more engaged, but then you kind of lose interest over time, right? And I didn't want all of that lost interest to be in the lie data, because then that would artificially, make it look different when that wasn't actually because they were lying, it was because they were disengaged, right? So I started flipping it, and for some people I would ask them to lie first and then tell the truth, and then for other people I would ask them to tell the truth first and then lie. So I did it in both orders and then like recorded. That's one of the things I'm recording in the data set as well. So that way I kind of can reduce the effects of that fatigue effect, distribute it through the data. Yes, sir? That's a great point, yes. So that's something, that was, the manager's response was partially for comedic effect. So that sort of thing. So the question that was asked is, did you consider ditching your manager's thing, because he actually put his arm up when he said, is Microsoft the best company to work for? He was like, yeah, and like did a little arm pump thing. And so, yes, that could affect the data right there. And so there's some not, in a real like experimental setting, that is something I would throw out, but I did leave that in there for comedic effect because I found it hilarious. So, but great point. That's a great point. Okay, so then the next thing I did in here was I'm starting to collect additional data about the test subjects as well. So just some extra random things. I'm recording gender. I'm recording age. Did you guys have the Brain Games? That show, is that popular here? All right, there's a show in the U.S. it's not that popular really in the U.S. even, but it's called Brain Games, and so one of the things that it's different like mental games or whatever that they show, and they test different things. And one of the things that they did was they had this one test where they were trying to differentiate between young people driving cars and like avoiding obstacles, and then more experienced drivers avoiding obstacles, and who could actually do better. Like younger people maybe had more alert reflexes, but older people have more experience driving, so like what would kind of win out. And it was interesting, the younger people actually did perform better, even though they had less experience driving in that test. So I thought maybe age would be relevant, because maybe the brain, like over time, starts to, who knows. So there's all kinds of stuff. So I collected just additional data. I also collected right or left-handed, because there's that old saying that your right or left hand corresponds to the dominant side of your brain, and I don't really know if that's true, but hey, more data is always good, in my opinion. So let me just collect that data, and I can throw it out if it's not useful. So just some additional things like that. And then I also did something where I was mixing truth and lies in a single session. And the reason for that is that you want to tease out those confounding variables, right? If I was, in most of these, actually all of these recordings I was doing, I was asking, truth and lie, like right after another, so they should be in a similar mental state. But just if there was anything that changed between the truth and the lie state, I didn't want to have it be something that was actually, it was predicting sessions rather than predicting truth or lie. Does that make sense? I'm probably not explaining this very well. But when you want to kind of remove all variables that you can. And so I said if I had something where I'm having them tell the truth and then lie and then tell the truth and then lie in like intermixed, I thought that might give me some better data right there. Because there is some truth, because like even over time, the same person, if you test them in the morning when they first wake up versus after they've had their coffee versus when they're tired versus when they're drunk, et cetera, you're going to get different like results. So being able to kind of handle all of those cases is another thing I'm thinking about. Okay, So I added some additional questions on the second thing. Those are there. Here's some additional test data that I ran, those kind of things. So this is kind of the cool stuff, is experimenting with feature extraction. So I tried a whole bunch of different things to how do you get the best features, right? How do you get the best data out of these waveforms? So one thing you can do is unroll the waveform, where I have all this data like here, and just kind of take each of those 14 values and then kind of separate them out, and then the next 14 in the next millisecond, and then kind of make a whole thing and like almost unroll that. And that works okay when when everything started at the same time and you can align those, but that can sometimes be difficult to align. Another thing is wavelets. So you can basically kind of divide things into these frequency bands in time, and that's something that's very typically done with EEG data. And there was actually a Kaggle competition around EEG data, and they found that these low frequency time bands was actually one of the most telling things for distinguishing between two actions, which was interesting and relevant to this. I also found a Pi EEG library open sourced. Thank you, Forrest Shengbao. I appreciate it. I leveraged that, and you could give it some EEG data and it would extract out interesting features. And so I messed around with that. I also was messing around with state machines and kind of the idea of hidden Markov models and breaking down this process. Because when you think about how I was then doing a marker at the beginning, right after I started asking the question. So think about the process. First they're listening and hearing the question. They're breaking down what that means. They're figuring out whether to tell the truth or lie. They are formulating their response. And then they're actually taking the mental action to vocalize that response. So there's kind of like this set of states of here's all these things that need to happen, and then is there a way to like state machine that up and then just grab the lie detection part of it. So interesting stuff. All right, and then comparing to the neutral brain state, that's the stuff that I was telling you about before, making sure I'm doing that correct normalization work to normalize across all brains, and having that neutral gives you that baseline to help you do that. And then working with ERP as opposed to raw EEG is another thing that I'm kind of messing around with, whether that would be more useful, just because that eliminates some of the noise. Ensembling, so ensembling is a huge technique in machine learning right now, and what that essentially means is that you're taking kind of several different models that calculate different things and then merging them all together. So you're taking an ensemble of models and having them work together. And so if you look at who is winning the Kaggle competitions right now, like it's always some ensemble of various things working together. And then finally, deep learning. So deep learning, I think, is, I honestly think this problem could be solved by deep learning, because when you think about it, this problem, it's waveforms, right? And it's waveforms that are everyone has kind of a unique signature, but this is basically the same problem as voice recognition, right? Speech recognition, because you guys have all seen audio files, right? And this is what our voices sound like, and everybody has a slightly different voice with different things. But if you do the normalization work across that, you can break down those waves and distinguish words from that. And so that problem has been solved by deep learning. Now, the reason I haven't done deep learning on this yet is I just don't have enough data yet. You need a slightly bigger amount of data, and I'm basically collecting data from people in my free time. So I haven't gotten enough yet, but when I do, I plan to kind of throw it at the CNTK and do some fun deep learning stuff as well. I think that might be a really good solution. Okay, so those are just some of the things I'm messing around with in terms of algorithms and features. The next steps, I'm collecting data from lots of people so I can predict generically from anyone. I'm experimenting with these features that I just mentioned, and then implementing a real-time feedback loop is the other thing. There are so many people on the Azure Machine Learning team and others who have helped me and gotten really excited and saying, oh, cool, let me give you this additional stuff. So thank you to all of them. So this headset is amazing, so much fun. Highly recommend moving things with your mind. That's so much fun. Azure Machine Learning is so powerful. Like, you can honestly do such cool things and solve such amazing problems with Azure Machine Learning. A little bit of knowledge and you can go a long way. And so husbands and managers beware. Mind control is next. Thank you guys so much.